Hello and welcome to Feeds for Shrimp Hatcheries webinar. My name is Luk Van Nieuwenhove and I am the editor of Hatchery Feed Management. This is the sixth in the series Trends in Aquaculture Hatcheries that we have been hosting in recent months. To ensure survival during the development of shrimp larvae, the right feeds at precise concentrations must be available at the right time. From live to manufactured feeds, shrimp hatchery farmers have to decide which are the best solutions for their farms, and this webinar will discuss different approaches to improve PL production through feeds. Thanks to the support of our sponsors, I&V Bio and Zeigler, this webinar is open and free. Each speaker will give a 15-minute presentation, and then we will get to a final panel session to answer questions from the audience. To submit a question, please type it in the Q&A box. And especially thanks to our assistant editor and webinar manager, Marisa Yanaga, who is making sure all our webinars work. Finally, it's my pleasure to introduce Cedric Simone, who will be moderating this webinar. Cedric is the Aquaculture, Nutrition and Production Systems Group Leader for the Livestock and Aquaculture Program of CSIRO in Australia. The aims of the group are to refine and develop novel diet formulations, culture systems, and value-added products to improve the diversity, sustainability, and efficiency of the aquaculture industry. The group engages in various research projects nationally and internationally. Their nutrition research program with Ridley Corporation aims at the commercialization of the microbial biomass Novak, a natural feed additive for wild leg and tiger shrimp hatchery, nursery, and intensive grow-out systems, which increases growth, feed conversion, and the resilience to diseases such as AHP and D. The group also delivers nutrition and production system solutions such as green water and biofloc to Biotuk and Minfu in Vietnam. Cedric has broad research interests, including the digestive physiology and nutritional requirements of crustaceans and fish, assessment of nutritional and health condition, novel applications of near-infrared spectroscopy, and the development of sustainable ingredients, functional additives, and formulations for aquafeeds. His research career, prior to joining CSIRO in 2015, focused on the aquaculture of spiny lobsters at the University of Tasmania, including the world's first development of formulated hatchery feed to successfully close the larval cycle and produce commercial quantities of spiny lobster post-larvae. Cedric, I hand it over to you.
Thank you, Lucia, and sorry for the very long bio. I didn't realize how long it would take. But good evening, everyone, afternoon and morning, wherever you come from. And thank you very much for attending this webinar, which I hope you find interesting and rewarding. And thank you so much, Lucia and the Hatchery Feed and Management, to give me this opportunity to moderate today the webinar. I mean, it's fantastic to be able to sort of, from all around the world come together, given the difficult time of COVID. And I think, talking about important matters for the shrimp industry is a great opportunity. So today we're gonna hear 4 great speakers from 4 different feed companies that specializes in hatchery and starter shrimp feeds. And like Lucia mentioned, the talks will be between 15 and 20 minutes, and we'll have a Q&A at the end. So please don't shy away, send your question in real time, but I'll take all those questions later on at the end of the 4 talks. So with that, I'll start, and I'll start introducing our first speaker, Luk. So Luk has been active in aquaculture since 1992. He worked for I&V as a Chief Operating Officer until 2012, being GM of different I&V companies in Thailand, Turkmenistan, and Russia. In 2012, Luk and Frank Indine started the Nuclei business founding I&V Bio, which became the biggest challenge in the professional life. Luk was the inventor of Artemia applications such as Artemia dryers, High5, SEP-ART, alternative decapsulation technology, embryo, I&V separation technology, Nuclei centers, and new generation diets. In short, recognizing the problems and needs of the market by finding practical solutions. Luk, if you could please share your screen, and yes. You can start presenting. Thank you.
Okay, I hope this is clear. Thank you, Cedric, for the introduction. Thank you also, Lucia. Welcome to this webinar. Welcome to my presentation, which is about daily deliveries of live Artemia Instar-1 Vibrio-free nuclei, a next generation product. Before 95, it was actually easy because it was mainly the Great Salt Lake who was available for Artemia cyst. But then came our expansion to Turkmenistan because there was a shortage on the Great Salt Lake, and we started to develop activities on the Karbagas Gol in Turkmenistan. And actually, this was the first time that on a commercial scale, another kind of Artemia was introduced into the market. On the right side of my presentation, you see what happened since then, because it's not only Russia, different lakes, it's also Kazakhstan with lakes in different regions, Uzbekistan, China, and so on. So there are many, many more resources than, let's say, 25 years ago. What is happening, that is all this product is ending up in one or other can with a different brand. The brands are coming from harvesters, but they can also come from distributors, middlemen, from anybody. And the problem is, once they exist in the can, you don't know from which lake they come. You don't know when they are harvested. You don't know the hatching percentage, and you for sure don't know the hatching characteristics, dynamics, like do they need an answer? How much an answer do they need? How long do we need to hatch them, and so on. So actually, the hatchery is buying Artemia cyst, like you see it here, and then it's up to them to convert this heap of Artemia cyst to pure live nuclei. So the harvest and the processing to dry cyst is actually the easy part. The difficult part begins when the dry cysts arrive at the hatchery and try to make from that Artemia nuclei. The reason why it is like this is because the dry Artemia cysts is the only way that the commercial company can offer Artemia cysts into the market. Otherwise, it would be a very, very difficult logistic. Once you have this Artemia cyst and you have to hatch them yourself in the hatchery, you know very well that light and temperature is the main factor. Also trying to keep the bacteria under control. The quality of what you bought is important, not always clear on the can. And if you did a good job and after 24 to 26 hours you have live Artemia, then you have to separate it. By the traditional methods with the double sieve, you will end up with a lot of damaged nuclei. This damaged nuclei is also ending up in your larval rearing tanks and is for sure a good substrate for Vibrio and bacteria in general. You also need the labor, and you need a skilled labor to follow the whole process. And when the process is finished and the separation is more or less done, you have to make sure that you follow some kinds of disinfection steps to get rid of your Vibrio. And now I refer to the NACA from a couple of days ago, which was presented by Patrick Sorgeloos, where we went over all the different hatching methods worldwide. And you see, to get rid of this Vibrio, some dip it in hot water. You will not believe it. It goes from between 60 degrees until 100 degrees that they are dipped in hot water to kill off all bacteria. Or freezing is another method, and disinfection by iodine or hypochlorite. So when in 2012, Frank and me were brainstorming how to actually come up with a solution and not just doing the business in Artemia cyst, which actually is the easy way. We wanted to come up with a real solution for the hatchery. So our dream was and is to make an Artemia nuclei live, clean, Vibrio-free, available for the hatchery manager or the hatchery worker that he can directly introduce into the shrimp tank. And this in a way that, in this case, you can see it is a spoon, that by taking one spoon, that you know exactly how many biomass he's feeding to his shrimp. I didn't quite catch that. Could you please to achieve that, we needed to start from the ground up. This is not just taking any shrimp hatchery and start from there and trying to make or to convert the shrimp hatchery into an outplay center. No, our outplay centers are constructed from the ground up, following a certain layout plan that was developed during our initial pioneering years. And this resulted into outplay hatching facilities, which look like that, where the everything is tailor-made, the tanks, the way that the aeration is done, the way that we are bringing pure oxygen to the tanks, the way that everything is evacuated to the separation. So this is how actually hatchery is looking. We also, of course, are taking care of the filtration of the seawater and the freshwater. Inside, you can see that the tanks, the water, the aeration, the way that we add the Artemia, all the conditions are under control. And moreover, because we are going from a local hatching facility at the hatchery of the shrimp hatchery, we are going to an industrialized way of hatching Artemia cyst. If you want to do it industrial, it means everything has to be controlled. Every step during the hatching has to be controlled, has to be written down, has to be keyed in. And this information is stored in the cloud forever, because this is traceability, so we can trace back what belongs where. And this program that you see here is a tailor-made program that's only working in our facilities worldwide. And because it is connected to the cloud, we have a continuous view of all the hatcheries worldwide, what is going on, where are they, and so on and so on. After our hatching time, we need to separate. Separation is so critical. We don't want to have any empty shell or full shell remaining into the product. For this, we developed our own separation technology, which is, by the way, patented worldwide. After the separation, we are adding our outplay in cooling tanks, where this we do to hibernate them. It's a kind of hibernation to make sure that they don't develop further from instar 1 to instar 2, because that would mean that they are losing energy, and this we want to avoid at any cost. During the cooling, we are also adding natural plant extracts, which are making sure that the Vibrio is not coming back, or that the Vibrio is suppressed. Once we are coming out of the cooling tanks, the Artemia nauplii are dewatered in a way that it's really becoming a paste. By the way, animals are still perfectly alive. So it's a paste, so all the external water is removed, which gives a consistent paste with a consistent amount of biomass per tray. In this case, these trays are 800 grams each. We have our internal quality control in every outplay center, where we, of course, check the instar 1 percentage. We check the presence of Vibrio. We check some viruses. We do that with real-time PCR. We check the survival of the Artemia in the tray. We check how much biomass, how much nauplii per tray, if the product is clean, no debris, nothing. And of course, this all has to be linked with the service to get the trays in time to the customer. And in time, I mean that is every day. And in many cases, like in India, it's even 2 times per day that we deliver. Together with the product, we deliver a certificate of analysis, which actually is confirming the quality in the tray, and is according to the agreements that we had with the customer when we started to make a deal. By the way, the analysis that we do is not randomly. I mean, if we are, the analysis that we do is a batch, so we are checking all the batches before we are sending out these certificates of analysis. That means that not one tray escapes our quality control. We also, of course, do external checks. In this case, it's a government in Thailand, which is an external body, just to make sure that our internal quality control is the same or is comparable with the external labs. Once our nuclei is in the tray and ready to go to our customers, we put them on ice. We put them in a cool box on ice. This cool box goes to the customer. The customer can keep that cool box with the trays on ice and use it in the sequence that he has to feed his shrimp or his fish. And the next day, we bring a new blue box with a new trays, and we take the old one back, disinfect, and the whole circle start all over again. Today, we have 3 of these products to offer. Instar 1, as I already explained, this is more than 90–95% Instar 1 Artemia at the moment of delivery. We also have the Instar E, where we enrich with algae, Celco, and vitamins. It's a standard format that we are using. And besides that, we have our embryo. Please don't confuse with shell-free. Shell-free is a dried embryo where the outer membrane is broken. So when you introduce that into your hatching water, the chances of leaching are important. In this case, it is a hydrated embryo where the outer membrane is still intact and there is no leaching taking place. Furthermore, we are, I think, the only one today in the world who is decapsulating without using hypochlorite. So we have our own method to disinfect without the use of hypochlorite, which could leave harmful chlorine residues. So what we did is solving for a big part the main problem of the hatcheries, that is the Artemia nuclei. We deliver it clean. It's a new way of approaching the market. We bring a real solution to the hatchery. If you have seen how many steps the hatcheries have to control to end up with a nuclei, with a healthy, clean nuclei, well, we do that on a daily basis. We deliver the hatchery whenever they need it. We also have the enriched nuclei, which is an advanced way of delivering extra nutrition or different nutrition, which most of the time is used from PL5 onwards, where the requirements, the nutritional requirements of the animal change. So we change with them by using the enriched nuclei. And also, I think it's very interesting looking to the future, because we can also enrich it with probiotics or with any additive that is smaller than, let's say, 5–15 micron, which the Artemia will store in its digestive tract. And by doing so, it's another form of bioencapsulation that can be used to feed your animals. And most important is Vibrio-free. It's unique, and I will come back to that, why it is so important that it's Vibrio-free. We started, as you know, in Thailand with a lot of difficulties. It was a difficult startup. Once we got everything in place, we start in India. By the way, now we are setting up our 4th NAPLI center in India. We are in Indonesia. We are looking for a 2nd place there. We have Vietnam, Bangladesh, Ecuador, and next year it will be Mexico. Here I come back to that importance of live feed and how to use it and treat it. The first line in green shows you a very typical hatchery feeding regime where Artemia or live Artemia are used together with diets. And you can see the average of 72% is not bad with a dry weight of 198 microgram per animal. If you then go to the blue line, you can see what I want to say there is I completely abandon diets. I don't use the diets. I use 100% live nuclei directly fed from the tray. And you can see that you have a better survival and a better dry weight. But if you then go to the gray zone and you're going to what many people unfortunately do is dip it in hot water from 60 to 100 degrees. In this case, we took 70 degrees at 2 minutes and then cool it down with water. You see immediate drop in survival and in dry weight. Same with frozen. even after 2 days frozen, you can see that the survival drops to 68% and a very low dry weight. And it continues like this. If you look at the 1 week frozen, you see it further goes down. So even if you're working with Artemia nauplii, it is important that it is live. We understand why people are dipping, and I understand why people are freezing or disinfecting it with iodine or whatever. That's to make sure that you don't introduce Vibrio into your rearing tank. But with our product, which is Vibrio-free, you have the ability to use it live and then to introduce like this as a feed. These are the underlying feeding tables, which I'm not going to go into detail. It just joins the first slide. Another one is the introduction effect of enriched Artemia into your feeding schedule. The first one is actually a normal feeding schedule where half, or let's say 50% is diets and 50% is Artemia that was hatched at the hatchery. And you can see the results there with the 63% survival and dry weight of 984. This is until between Z3 and PL12. The next one is exactly the same as the previous one, but there, so also the same diets, the same amount of diets used as in the first one, but we used the I&V Bio Instar 1, which gives a slightly better result. But what is more important, it is more consistent, because we do deliver Vibrio-free, we do deliver whole animals where there is no leaching, and we do deliver Instar 1 where all the nutrients are still present. And the last one is the same as the previous one, but we switched from PL5 onwards to PL12 with the enriched Artemia. As you can see, it is not a phenomenal increase, but let's say that it's the same as in line 2, which means that if you start feeding enriched from PL5 and to PL12, it's actually a very good idea to do so. And I will immediately tell you why. Because in both cases, in Instar 1 and in Instar E, you're feeding the same amount of biomass. In this case, it's in a tray of 800 grams. And I also know that if you feed enriched, it's an Instar 2 or an Instar 3, that you have less animals in your tray than what you have in an Instar 1. So if you have less animals in that tray, it also means that we used less Artemia cysts to generate this kind of nauplii. So it becomes cheaper. And the enrichment and the extra labor that we put into this enrichment don't balance against the cost of nauplii. In fact, the enrichment and the labor is cheaper than the nauplii itself. So you have 800 grams very well enriched Artemia at a lower price than the normal Instar 1. Although that the results show in the previous slide that you have an equal or better result. So it will help the hatcheries to control better their cost of Artemia use in the hatchery. That again is the feeding regime that is supporting the previous slide. Now I'm coming to the end of my presentation, and I think many people asked me already, when will there be Artemia replacement? And I will say always the same, one day, but not today, and probably not tomorrow. I know this because after extensive research during the past 20 years, where I was involved myself in the years that I was working in I&V. But just take a simple test. I'm going to be fast here. Just a simple test. You feed live Artemia 100% to your larvae. And you will see that you will have a very nice survival and a very, very nice dry weight. Now, you don't use any Artemia at all, but you feed 100% diets from Zoea until, let's say, PL5. 100%, no Artemia. Well, I think not many of your shrimp will even survive until PL5. And then I'm not talking about survival of dry weight. And another example is if you take nauplii and you would dry them and make another, just dry them and use that 100% to make another new particle. If you would feed that into your tanks, your result would be close to half of your live feed. So besides that, you know that live feed is triggering a better feeding response. and you avoid sinking to the bottom. It's natural bio-encapsulated, so you don't have any leaching. And and if you compare it with artificial dyes, you don't have the empty weight, such as the binders and the non-nutrients. So what is also interestingly, that most of the current Artemia replacements have Artemia as part of the formula ingredients. There is no more to say about this. And so the only thing I can do is thank you for listening. Thank you, Lucia. Thank you, Cedric.
Thank you so much, Luk. Very, very interesting. And yeah, a great example of innovation there. All right, well, we'll move on to the next talk. So I'll introduce Leandro Castro. So with almost 20 years of experience in aquaculture, Leandro has worked in academia, in production, and in feed manufacturing. Born and raised in Brazil, where his career started, Dr. Castro worked for 10 years in one of the most advanced aquaculture nutrition laboratories in the world. The main focus of his academic research was to understand how different formulation strategies impact animal performance, water quality, and biofloc dynamics in super intensive aquaculture systems. Part of his PhD research was done at Texas A&M, AgriLife Research Laboratory, where he worked on advanced super intensive biofloc dominated indoor aquaculture systems. Leandro then moved to the private sector, serving as a production manager of the biggest commercial indoor shrimp farm in the United States. In this role, he was able to apply fundamental academic knowledge of biofloc systems to commercial scale production. He joined Zeigler Bros as research project manager in 2017, where he set up a research laboratory in a commercial feed mill for development of improved aquafeed technologies. So thank you, Leandro. If you could please share your slides.
Good morning, everyone. Thank you for the chance to have this presentation. Let me share here my screen. Can you guys see my presentation?
Yeah, it's okay.
Okay. So thanks everybody to have a chance to, I'm gonna have a chance here to talk to you about the newest innovations on the liquid feed technology program we have at Zeigler. I'm gonna show you the Easy Artemia Ultra. In this product, I can show you how the best just got better. Our liquid diet improvement project began with the classic Easy Artemia, and this is a product that we have in the market for the last 25 years, and it has proven its high performance in commercial systems worldwide. This product was developed as a synthetic substitute for Artemia, and has become a global standard for the industry in this segment. Easy Artemia Ultra was formulated to exceed the attractability, digestibility, and the nutritional value of Artemia nuclei. Over the years, the best ingredients have been incorporated into this highly digestible microparticle, which is precisely manufactured and sized for maximum consumption. This microencapsulation matrix protects not only the sensitive pigments, but all the other ingredients like fatty acids, enzymes, vitamins that we have in the formulation. Easy Artemia it's also supplemented with VPAC, which is our Zeigler Immune Modulator, and combined with the probiotics, the product was designed to provide a health supplement to the shrimp larvae. So the question would be, how could we improve yield on the best? Well, 3 years ago, we decided to improve Easy Artemia, and we tackled three main areas to improve the product. One of them was improve the formulation by itself, where we could incorporate in the new formulation powerful new ingredients like new proteins, lipid sources to improve animal performance. The second area of focus was the manufacturing by itself, where we could find ways on a development process to improve our manufacturing process, to squeeze more nutrients into these microcapsules, improve also the digestibility of these microcapsules, and make the capsules more buoyant. So there's going to be more longer available to the animals in the water column. And everything, of course, keeping the stability as the classic easy Artemia is known for in the market. The third area was to improve larval fitness. So we developed technologies to precise deliver functional probiotics in the diet. And also we found different blends as a supplementation to improve gut health of the animals. Talking a little bit more about the formulation advancements in Easy Artemia Ultra. The process to improve formulation started just by selecting the ingredients we have available in the market. And not only the selection, but also blending them together into a product that meets the nutritional requirement of the animals. It was a key part of the process. And everything should be cost effective and manufactured such how that would be in a usable form. For Easy Artemia Ultra, we started by selecting the highest quality marine ingredients that we could find in the market. And in our highly replicated larval culture system, we could explore and fine-tune the combination of these ingredients, and also to find the best way to balance the nutritional value of the product, everything to maximize animal performance. We also not only explore the macro ingredients, but the micro ingredients like the vitamins and the minerals in the diets, in this new diet. Formulation worked very well. Formulation not going to work very well if you don't have a good way to deliver these packages to the animals. That's why one of the area we decided to improve the manufacturing process, and which reflected on the physical characteristics of the product. Right now, if you have a chance to use the classic Easy Artemia, and when you have a chance to use the new product outside macroscopically, you're going to be the same, but in a small scale, everything is going to be different. And it's because we put too much effort to improve physical characteristics of the particles. Here in our lab in Pennsylvania, we did a very unique basic discoveries that could fundamentally improve this microencapsulation process. And with these discoveries, we could have huge advancements to better incorporate, for example, ultrafine microingredients into these highly digestible particles. And I want to mention that this matrix that we have, the feed, it's a very stable in the water and doesn't leach in the water as, for example, dry larval diets. Another advantage we could get to improve the physical characteristics was improve the buoyancy. So the product stays longer in the water column. And we developed techniques to benchmark this product buoyancy, and we can have a huge advantage by using Easy Artemia Ultra. The biosecurity risks from freshly hatched Artemia have been well documented by leading researchers for decades. That's not a new information. We know that the Vibrio contamination is one of the big issues associated with improperly hatched or disinfected Artemia nuclei. And very often the manager put huge efforts and money to control this Vibrio infection in this practice in hatchery. On the other hand, Easy Artemia is sterilize the product through acidification. And with this technology, we can achieve a 2-year shelf life on the product. So the product, whatever, once you buy this product, you can stay in your shelf for 2 years, no problem. And for Easy Artemia Ultra, it's not any different. We're going to keep these characteristics, and we went beyond. For this new product, we developed new organic acid blends that's going to help not only in the product acidification, but also to contribute on the microbial control of the system. And I think that I want to highlight is the classic, all the liquid Zeigler leak products like Easy Artemia Classic, and of course, the new Easy Artemia Ultra is PCR tested. So every batch we test in a PCR to make sure that there's no pathogen associated in this diet. So you're going to receive a very clean and secure product and shelf stable. Another technology that we could incorporate in Easy Artemia Ultra came from the last three years of research. We could incorporate targeted functional probiotics in the feed. For Easy Artemia Ultra, we are using two different types of bacillus strains coming from our rescue and remediate product. The rescue, it's a strain that's selected for their effectiveness against the Vibrio, pathogenic Vibrio species. And its function, it works very well when it's offered to the animals, and it targeted to populate the gut health of the animals to, of course, contribute to decrease the Vibrio count on animal gut tract. Remediate has a different bacillus strains. Remediate has a bacillus strain it's very effective to break down organic material, controlling the ammonia in the water. And you're gonna have this benefit when you use this new product. Each blend is adding a very high concentrated, so each blend is adding on a rate of 10 to 7 CFU per gram, and that's what we're talking about on a wet weight basis. So why it's very interesting to work with these two probiotics in Easy Artemia Ultra. It's because they are targeted. So we developed the technology to add, for example, rescue that is our target is to introduce in animal gut health. So we found a ways to keep that stable for 2 years into the microcapsules. On the other hand, remediate, since it's target to treat the water, it's in a product outside the capsules where we call liquid fraction. So it means when you use the product, you don't have only the advantage to use a highly nutrient balanced diet with a very nice ingredients, but also you're going to have a targeted functional probiotics. They're going to act differently in the system to help the animals to stay healthy and, of course, to control the water quality. Visiting shrimp hatcheries all over the world, we could see a wide feeding strategies. So pretty much every system has their own feeding strategy when you're talking about hatchery systems. But globally, there has been a long-term trend towards reducing Artemia nuclei feeding rates to rely much more on artificial feeds. And that's where Easy Artemia Ultra can be successfully incorporated into the existing protocols, because you can use that in many ways. Here I can show you 3 different strategies where we can use this new product as a supplement of feeding products. Some hatcheries has been incorporated that by using Easy Artemia Ultra after discontinue Artemia nuclei usage, and they have been reported in commercial system reduction of cannibalism and improvement on higher survival. When you use Easy Artemia Ultra as a partial replacement, also from our laboratory research and from field studies, we could demonstrate an improvement in lipid deposition in animals. We improved the growth and survival compared to the tanks that were fed with only Artemia nuclei. In addition, this results in cost reduction and improve on the profits. Third strategy, it's a full replacement. Easy Artemia Ultra has been demonstrated a fully replacement of Artemia as a diet. Because in this situation, we can fully eliminate the need for additional capital and labor expenses associated with Artemia hatching systems. Not only talking about that using Artemia nuclei or Easy Artemia Ultra, you can significantly reduce the risk of pathogen contamination while you're providing good tools like to keep the targeted probiotic you have in this diet. Easy Artemia Ultra, as the most recent diet that has been released by Zeigler, has been developed in our Zeigler Aquaculture research system. It's a very nice system that we have here in Florida, and we pretty much have the opportunity to run trials in any of animal phase, which give you it's very powerful for us when we when we want to come up with or improve products that we have in our portfolio. Talking a little bit more specifically about larval feed system where Artemia was developed. This system, it's a highly replicated system and give us huge statistical power. Combined with the precision on the control of feeds and feeding, we can see minimal difference. We can see how the minimal difference on the feeding formulations or on the manufacturing can affect the animal performance. And in this way, we have been developing very unique knowledge about larval nutrient requirements. And one example of successful product that came out of this larval feed system, it's Z-Pro. Z-Pro, it's the newest Zeigler dry larval diet that was carefully designed in our lab, very similar way that we designed Artemia Ultra. And since Z-Pro is a little bit longer in the market, it's showing a very good, we're getting very good results from the customers all over the world. So we are confident that Artemia Ultra as Z-Pro going to be very successful. So in this system, we tried to see if we could accomplish what we targeted 3 years ago. So could we improve the best? Yes. Artemia Ultra in the ZARC trials could provide 15% higher survival and 26% could provide 26% larger PLs, while we could have 60% higher harvested biomass. Those, so it means we accomplished what we targeted 3 years ago. But what would happen if you put Artemia Ultra against Nuclei? Well, we use two different feeding strategies. On the left column, I know it's a little bit small, but I can explain to that here on the left column. These are results where we used only Artemia Ultra and only Artemia Nuclei as a feed source. So we could see that the nutrient values we have on the new product could be effective or could replace Artemia Nuclei in 100% replacement. And in this situation, we incorporated Artemia Ultra and Artemia Nuclei with dry larval diets like a part of a feeding protocol that's very typical in commercial hatcheries in Asia and Latin America. And in both feeding strategies, we could not see no differences in survival, in average harvested weight, or in harvested biomass when you fully replace Artemia Nuclei with this new product, Artemia Ultra. And then you could say, yeah, that's nice, but what would happen if you bring Artemia Ultra in the real world? Because everything you have been shown so far is just in a very small scale in your lab. Well, we did the test, and we did a beta trial in a commercial hatchery system in Mexico. And we used in this situation, we used the three different approaches. We wanted to see what happened if we use Artemia Nuclei only as a supplement, and what would happen if we use Artemia Ultra as a 50% replacement, or what would happen in a commercial situation when you fully replace Artemia Nuclei with this new product. Well, the result does not surprise us because we have been collecting nice results from our lab, but in a commercial situation, we could have 15.9% more PLs harvested when the treatment that was supplemented with Artemia Ultra. Also, the PLs were 5% larger. In a 50% replacement, we could generate 6.3 more PLs. And then the treatment that was fed with only Artemia Nuclei. In this situation, it was slightly smaller, but there was no difference, statistical difference between them. On 100% replacement, we could have 14.2% more PLs harvested in the tanks that were fed with Artemia Ultra, and the annuals were also 39% larger. This is a very significant and very important result when you see the comparison of this product against Artemia Nuclei. And then plotting results like numbers from the commercial real world. What would happen if you use Artemia Ultra, at least just a partial replacement? Could we make money out of that? Yeah, we ran economic analysis, and in this situation, if you just use it by like a partial replacement, you could have 7.2% more profit by using Artemia just than treatment that you use only Artemia nuclei. So in this situation, you can, and with those results, I can show you that not only you're going to have a very nice feed that's going to provide better animal results, but also going to bring you more profit, which is very important for any commercial systems. So to summarize everything, Artemia Ultra can bring many benefits, as I showed you. One of the things, it's very nice, it's easy. It's easy to use, and it has a long shelf life. So it means when you buy it, you can store it in room temperature for 2 years. So you don't need to worry about that. But of course, we recommend refrigeration of the product when we open the jug. The combination of advanced formulation and the enhanced microencapsulation technology that we put too much effort in the last 3 years, resulting in a precision sizing, in a higher particle nutrient density, a better product digestibility, and everything combined improve the larval performance. Remember that Artemia Ultra is sterile, so we eliminate the potential to introduction of pathogens, while at the same time you deliver functional probiotic blends that are going to be helpful for the animals and to the tank ecosystem. And based on the laboratory and the commercial hatchery results, we can easily incorporate the Artemia Ultra in a different ways, as a supplement, as a partial replacement, or as a full replacement, and significantly improve the profits in your systems. Artemia Ultra is one part of the family, one part of the Zeigler ZBI hatchery products that's going to be released pretty soon, and you're going to have access to this new and nice product pretty soon that's going to be working very well with other Zeigler products. Thank you.
Fascinating. Thanks a lot, Leandro. It's great to see that there are products out there that can basically replace Artemia. It's great. All right, so the next talk is from Jef Peeters, Global Product Manager for Hatchery Products BioMar. So Jef has more than 25 years of experience in shrimp nutrition and larviculture. He graduated in biology from the University of Alicante and received training in shrimp nutrition at the University of Ghent. He began his professional career with a research post at the Sinaim Espol Research Station in Ecuador, after which he has collaborated with several international companies in Europe, Africa, Asia, and Latin America, focusing on the development and formulation of shrimp larval and on-growing feed, and advising aquafeed manufacturers, hatcheries, and farmers. 8 years ago, he joined BioMar as a research dedicated to the nutrition of crustacean larvae. Today, he's the Global Product Manager of products for shrimp larvae at BioMar. Thank you, Jef. Yes, your slides are up already.
Okay, perfect. Thank you very much, Cedric, for the introduction. And thank you to Hatchery Feeds to the opportunity for this presentation. And thank you everybody for attending this webinar. I'm going to talk a little bit about fast growing post larvae and how an integral approach to fast growing post larvae has given some fruit. So it's a bit of case study, and the case study is a bit the story of how it was achieved to harvest PL9. So until now, we are still okay, with a size of 170 to 180 PLs per gram after 50 days in the hatchery. In order, so when we looked into the case, so how did this come? So we identified 3 pillars, which were key to achieving these results. One of the pillars is nutrition, of course. The second one is genetics, a very important pillar. And third, but not least, management. So advanced hatchery management, because it's really necessary in order to maintain survival and growth in these tanks. This case study was done at the BioMar hatchery together, which is using a genetic program which is run by the University of Las Palmas de Gran Canaria. And for this presentation, and of course for all the work which has been done, not the nutrition part, but genetics and the management, I would like to give thanks to Walter, to Juanma from the Universidad de Las Palmas, and to José Agustín. So first we go into nutrition. So we need a formulation for fast growth feeds. So feed that can sustain fast growing larvae. It might sound a bit repetitive, but the formulation has to be absolutely complete. So you have to have all your amino acids in there, all your fatty acids, other elements of the lipid classes, all the vitamins, microminerals, you name it, everything has to be in there. It has to be balanced. So there's so many stuff that needs to be balanced within a diet that you won't believe it. Your calcium phosphorus ratio has to be balanced. Certain amino acids have to be balanced. Fatty acids have to be balanced, and you'll go on. So it is a balanced formulation. It's not for nothing that, for example, in Spanish feeds, they call it balanceado. Then, and third characteristic of the feed is that it had to be concentrated. So it has to be concentrated. Everything that we put in the feed, be nutrients or ingredients or specialty additives, has to be in there for a reason. So we are not using any fillers that can afterwards potentially dirty the larval rearing tank. So everything has to be in there. We also use a superior raw material quality, which is very important. The fish meals we use is not the general fish meal that you would use for a grow-out feed, and so on. So really as cold processed possible raw materials. Functional ingredients that have been screened by us, and very careful processing and quality control afterwards. So that is what goes into a formulation. In order to be able to illustrate the next slide, let me illustrate a little bit again, a recap of how shrimp grow. They have a discrete growth, as it is called. So they shed their exoskeleton. After they shed their exoskeleton and the new exoskeleton, which is below, is still bland, they puff themselves up with water. So they completely inflate with water. Then they hide a little bit somewhere. Then the new exoskeleton hardens. Then, and little bit by little bit, the animals, what they do is they replace the animals that they puff themselves up with. They replace it with the water that they puff themselves up with. They replace it with meat. And once all the water is replaced with meat, then we repeat the cycle again, and the shrimp molt again. Visually, this would be a bit like this. So we have our shrimp, which then sheds its exoskeleton and starts puffing itself with water. So this is the new size. This is very quickly, it goes very quickly, the upper. Then the exoskeleton, the new exoskeleton hardens. Little bit by little bit, the shrimp starts replacing the water, which is the light blue, with meat, which is the purple, until everything is filled with meat and the cycle starts again. So, having given that, so in order to go to a fast growth feed formulation, so we need a feed that facilitates smooth and rapid molt. So, which is key in the formulation of this feed. This is something that we want to attain. We want quality protein and amino acids, of course, for meat formation in order to replace the water. So we need high quality protein as building blocks. Not only protein as energy, although also they need loads of energy. So we need protein, some of lipid as energy, but we need protein as building blocks for the meat. As the molting cycle is accelerated, these animals, they need precursors to make the molt cycle hormones so that their internal hormone management can follow the fast growth. They need minerals. So minerals, for example, to think of something, in order for the exoskeleton to harden, you need specific minerals. Also for the growth, you need specific minerals for fast growth. Phospholipids and nucleotides, which are absolutely crucial in growth of fast-growing animals. In fact, also for growth of any fast-growing organism, so phospholipids, especially for the brain system and everything, and the nucleotides for the growth. Then we need an in-feed probiotic to maintain the gut health. And how do we do this? So we base ourselves on extensive literature data, quite a few of internal R&D trials, and about 30 years of know-how in formulating feeds for larval shrimp and growing shrimp. So I don't concentrate on all these individual trials that we have run. I go directly to the trials that we ran in the field to corroborate the final results. First is an Ecuador trial that we did against various commercial feeds. Here are the data. So small tanks, 100 naupii as a starting density, and we harvest at PL2. So there we go. We have our results, and we see that the first feed that we see in blue, the fast growth feed, has about 16% quicker growth than the mean of the other brand studies in there. But we also monitored survival and stress test, but for the moment we are focusing on wet weight, on fast growth, so we are going to stick to that characteristic. We also did a field trial in Ecuador, again with Vaname. All our trials in here are with Vaname. Location in Ecuador, commercial densities, 150 per naupii per tank, bigger tanks, about 50 tons. 2 replicas. We are working in a commercial environments, not always possible to take over the complete hatchery to have a lot of replicas. The feed, as is customary, the control feed was a mix of different feeds, as people tended to do and still do. And we tested our fast growth feed, which was only the fast growth feed. 2 tanks were harvested at PL15. And we see here the tank that was harvested at PL15 that was fed with the fast growth feed at a 17% quicker growth than the control mix of diets. The next day, 2 other tanks were harvested. And again, we see a 13% improvement in growth. We also did some field trials in Mexico more recently. Trial 1, where we go in a normal density, around 150 naupii per liter. The control treatment, again, is a mix of feed, whereas our treatment was almost exclusively fast growth feed. And as is customary in Ecuador, in Mexico, the animals were grown until PL5. After PL5 in Mexico, they go to a nursery. So we had 3 tanks on fast growth feeds. We had 3 tanks on the control feeds, and we see again 36% increased weight with the tanks given with fast growth feed. Also survival improved, but again, this is not an important parameter here. Second trial we did in Mexico, another hatchery, high density of naupii up until 500 naupii per liter. And all were given a mix of feed. So even the fast growth feed was given in a mix of other feeds. So around 30 to 40% of the feed was the fast growth feed, again till PL5. We see the weight was more or less the same as obtained, which we didn't pursue it, but kind of gives us an indication that maybe mixing of feeds might not be the best of ideas. Then also the survival was improved in this trial. Then a last round of trials, which was a Vietnam trial under more controlled conditions. We were rearing the animals from PL1 till PL10 with fast PL growth feed. Again, we tested against 2 brands available on the market. We had increased wet weight, Of course, the length followed, so increased length also, which especially in the Asian region also is an important parameter, whereas in the Latin American region, we go more by size. Then stress test survival was enhanced, which also gives a bit an indicator of the robustness of the larvae. So bigger larvae, more robust. And then of course, overall survival, but again, not that important at this moment. So these were the trials that we did with the feed that we formulated to achieve fast growing larvae. Now, what happens if we throw into this mix, if we throw genetics and of course, the necessary advanced hatchery management into the mix in order to get fast growing larvae. So the genetic program that is applied at this hatchery, it's a genetic program which is based on the best linear, unbiased prediction of specialty characteristics. Now they are in the 4th generation, going to the 5th, but keep in mind also that genetic programs have started in Ecuador already a long time ago, already before 2000. I remember Matt Briggs starting up a program, Sequest, and since then programs have been running in there. But then again, this program has started 4 years ago and it's really quite spectacular in its results. So characteristics which are being selected for until the moment is growth, survival, flesh quality, nutritional value, and resistance will be taken into the selection program soon. Another characteristic of the program is selection in low consanguinity. This program, or this kind of analysis of the data, it takes into account factors outside the purely genetical sphere. So for example, the phenotypical influences, so the environment. And one of the things that we already know and that we will see confirmed is that there is a clear genetic correlation between hatchery growth and growth on the farm. So a quick overview of the selection. You can see here that at the first one, the crossings were aleatory, but then as it progresses, the crossings are very much targeted according to the selection criteria of the characteristics. The selection, also important to say, is carried out not with the animals that performed well on the farm, but also with on their siblings that stayed in the nucleus breeding center in order to downplay contamination with pathogens. This is a characteristic. So what is happening? So we go to 183 PLs per gram. This is a graph of what used to happen before. This is a graph of 2010 from Quires. This was published in the shrimp book. Here you see total length and weight of different larval stages. Now, if we go, we see the weight, but we are going to introduce a second axis with a measurement which is used a lot, which is how many PL per gram. So 1 milligram animals, 1000 PL per gram. Normally at PL 12, which is the typical harvest age, we would expect animals of 300 to 250 PLs per gram, a little bit bigger than actually this graph says. Let's say let's go up to 200 PLs per gram. But what do we get now? We get animals of 183 PL per gram, and we achieve that number at PL 9. So we go from 250 animals per gram to 180 animals per gram in an earlier stage. So bigger PL, and we get them 6 days earlier. Again, a growth graph, what happens at the hatchery. So this is what happens in the hatchery, so the red dots. Whereas in the blue line, you can see where the range is, where the rest of the hatcheries of the country are at. So let's see a little bit of an economic analysis of the extra gains that we get. So classically, a growth cycle of 21 days, we harvest PL12 at around 250 PLs per gram. The scenario where we are now under is a growth cycle of 15 days. We harvest PL9, ship it to the farm at 180 PLs per gram. Let's suppose medium-sized hatchery, 10 million PL per cycle, and an ex-hatchery sales price of around $3.5 per 1,000 PL. This might not be a reality in your country, but it's a bit an average of what I've been hearing around. So we see the harvest sizes, we have the cycle duration in days, and we have 28 days, because I'm counting in a 7 days cleaning and drying cycle, because we want to do nice, we want to maintain nice biosecurity. This means that in the first scenario, we can do 13 cycles per year, and in the new scenario, we can do 17 cycles per year, which leads to an increased PL production per year, and which leads to increased sales per year, 27%, so almost 30% more sales. So this is quite spectacular. Moreover, having much more hatchery cycles, if something happens during one cycle, you would complete batch of larvae that you have to throw away. At least you still have 16 cycles, whereas in the first scenario, you would have left only with 12 cycles. Advanced management, which is absolutely necessary because these animals grow very quickly. They really grow very quickly, and you get a lot of biomass and a lot of feed in your tank. So you have to really provide these animals. They are extremely voracious. You have to provide them with all the feed because you don't want to depress the growth that you got through the genetic program due to underfeeding. And secondly, you got to monitor your water quality. Densities that they are using is 160, 170, so normal densities more or less. Water, oxygen is very important. So the need here, we get to the need where we need to use pure oxygen. Temperatures, we go as close to 33 Celsius without surpassing. pH, very important to keep the ammonia toxicity in check. So keep it as below 8 as much as possible, and keep alkalinity of 120 to enhance the buffering capacity. We monitor, of course, our ammonia closely. Salinity goes from 13 nauplies, from 30 ppts in naupli till 18 ppts in PL1. And then gradually we go down because of some of the farms are located in very low salinity waters and very aggressive feeding, as I already told. So we monitor all the time and keep 80% of digestive tract full. Probiotics are used. We use 1 to 2 exponents higher than the Vibrio concentration. That's what we aim for. So the harvest, I already told you, 170 PLs per gram in 15 days. To mysis, we don't take 9 days, we take 6 days. And at PL6, the branchii are already fully developed, as we would normally expect to arrive at in PL10, 11. Feed on dry weights is around 10 kilos that is given. But we have, of course, 150 animals, so we need today. That would be the feed that you would be using for these animals, even if you achieved this number at PL 14, 15. And of course, we give a 700 to 1,000 naupliae of Artemia purpose larvae. Hatchery has increased its output. Also, as I have announced before, quicker growth in the hatchery brings with it a quicker growth in the farm. So we're getting 20 gram animals in around 60 days. Again, confirming the clear genetic correlation between hatchery growth and the growth on the farm. And absolutely, we established the need for fast-growing feeds for these fast-growing larvae to ensure good results and to don't depress the results. So again, repeating again, keys to achieve fast-growing larvae: first, nutrition; second, genetics; and the third, management. So without these three, you will not get the fast-growing larvae. I thank you very much for your attention, and I will leave my place for the next participant.
Thank you, Jef. No, very great talk, and I love the biology 101 on how a shrimp molt. I thought that was refreshing. And yes, so the next talk we're gonna go with is from Thomas Raynaud, Global Products Manager for Bernaqua Epicore. So Thomas is a Global Products Manager for Bernaqua and Epicore, which are two hatchery diet companies from ADM. He's a marine biologist that worked in aquaculture for more than 16 years in many countries and with various species of fish and shrimp. He managed different R&D aqua centers, participated in different scientist missions, and has a long experience in farming systems as biofloc, aquaponics, and intensive nursery. For 7 years, he is working as a business developer and product manager for the Aquafeed company, sharing his technical experience in fish and shrimp culture. Thank you, Thomas.
Thank you, Cedric, for the introduction.
Yep, you can put it in full screen. Perfect, thank you.
Thank you. So thank you, Cedric, for the introduction. Thank you, everybody, thank you for the organizer to let me the opportunity to introduce this presentation. So I'm going to talk about the shrimp nursery, the management and the feeding management. So it's a large topics, nursery, so I'm going to try to resume in 15-20 minutes what is a nursery system, and also how we can improve the feeding management. So if we go more on description of nursery system, so traditionally, as classic cycle of production that some of you know already, it's we have the hatchery stage where we are producing post-larvae, and after we transfer the post-larvae directly in the pond to go in the grower stage. So some people start, and many people start to produce more in nursery system. So the objective of the nursery system is to create a transition stage where we're going to transfer directly the post-larvae from the hatchery, not directly to the pond, but in nursery tank, where we're going to produce some juveniles. And after the nursery step, we can start to transfer the juvenile directly to the pond. So the advantage of the nursery, in fact, it's a better biosecurity, because we are in a closed system and we can protect the animal against the disease or different predators. There's also a big advantage that we have with nursery. It's we are in control, of full control of water quality. Many times we are working in a very small water exchange, so we are able to control the water quality. As a feeding point of view, because we are in a small volume and we are in a controlled condition, we are able to reduce the FCR, so the feeding conversion rate, and we can also reduce the quantity of spoiled feed. So one of the main interests for the nursery as a farming point of view is to increase the number of crops per year. So thanks to the system of nursery, we are able sometimes to add 1 or 2 crops of production per year. Another thing that we can see, it's when you have an issue on your farm, example, a disease, or when the season starts, it's still a little bit cold, we can use the nursery system to allow the quarantine. So we can use this system to protect from the issue your animals. And at the end, what you're going to produce is some juveniles stronger and more resistant when you transfer them in the pond. So concerning the tank design, we can find 2 different tanks design on the field. So the first, and they start like this at the beginning, it's round tanks where you have in the middle a central drain that facilitates the removal of solid waste. It's very easy to manage and very cheap to build. The only inconvenience that we have this system is you don't have good and optimistic space utilization. So the other method that exists is the RASway. And the RASway, so the most and the biggest advantage that we have is we have an optimal space utilization. Sometimes it can be quite expensive, depending on the material that you want to use, but it's an advantage for the space utilization, and sometimes in function of design, it doesn't facilitate the removal of solid waste. So depend of your area, so you can choose round tanks or RASway, depend of your area, your facilities. Concerning the hardware of guidelines, so it's very important to protect your nursery system from the external environment. So we require to use a full liner or concrete to protect and to have the wall very well protected. It's a system where we are working in hyper-intensive condition, on full condition. So this means we need to have a very good aeration. First, because we have a high level of oxygen demand in the system because we have many animals and we are in a closed system. So we advise to use an airflow of around 35-50 cubic meter for 100 cubic meter of water. Something very important also is not only the oxygen that you're going to supply in your system, but it's also the water and the aeration movement you're going to create in your system. It's very, very, very important to go in convection and not in circulation because you need to maintain all the organic matters you are in the system in resuspension. It's very, very important to have no sedimentation because if you have sedimentation, you can start to have some problem or some issue or some pollution of water. Something that we advise also, it's in the best case, is to shade the facility to reduce the phytoplankton development, and because after we can have a fluctuation of pH and oxygen in the system. So to have a good shading, it can be very important. And for sure, when we are starting the nursery, when we are starting to fill the nursery system, it's very, very important to have a good water treatment. So there is different possibility to make a water treatment. The easy way is to have a chlorination at the beginning in a tank reservoir outside the system, or you can use different technology like ozonation or carbon filter or different kind of this technology. So when you start the nursery system, the seeding, it's something very important. The main critical point is to be sure about your PL quality and the health of your PL. So you need to be aware and you need to know exactly what is the origin of the post-larvae, what is the genetics, do you know more about the transport time? Example, we know after 10 hours of transportation, it can be very complicated for the post-larvae and we can start to have some weak PL. So it's very important to control and to have the shortened time possible in terms of transport. It's also very important to have your own SOP. So you need to create your quality assurance. When you receive the PL, you need to count, you need to make a body weight, and you need to check the coefficient of variation. It's very important to have, as soon as the maximum possibility to have a good variation and good homogeneity of PL size. Sure, now we know it's very important to require some PCR tests to be sure there is no pathogen in your batch, and to make some microscopic observation to check first the PL size, but also to check if you have some issue like necrosis or fungi in your PL. And what we advise for some of you, you know this, is to make stress test. So stress test, it's a very simple test where you're going to put your animals in a fresh water example, and you move your water to see what is the behavior of your animal, if they are weak or not weak. When you are making the stocking, after to check everything, it's very important to have your water already prepared with a stable bloom and probiotics. You need to prepare some days before the seeding your water. It's very important at the moment of the transfer to make a good acclimation of temperature and salinity, and to have a little bit some feed already inside the tank to help the animal to go directly to the feed. So at the beginning also, because we are very small animals in a big volume, we advise to make an overfeeding during the first 3 days. So we need to put a lot of feed at the beginning, first to help and to motivate the system to accelerate in terms of bacteria balance, but also to provide at the maximum possibility the feed for the animals. So the water preparation, we can use, and we know there is a benefits to use some probiotics. The probiotics help you to have a good water treatment because first they help you to make a better digestion of the organic material. They help you so to reduce the ammonia level in your system. And when you want to work at biofloc level, they can help you to initiate the production of floc. So the disease control also, it's very well done thanks to the probiotics, because you can produce some antimicrobial agents and you can have a good competition with the bad bacteria in the system. So probiotics help very well your system in the nursery condition. So what we can advise when you have a system where you have medium water exchange, it's to make a preparation and a probiotics culture before to put the probiotics inside the system. So here we have an example with one probiotics, so the Bactosafe H from Bernaqua. We mix and we put these probiotics inside the 200-liter tanks. And after we are mixing with water, 150 liters of water. We need to add a carbon source. It can be sugar, molasses, and rice. Also, it's important, rice bran, because it's very easy to find and it's very cheap, and a little bit feed. So like this, we're going to start the maturation and the fermentation of the probiotics. And this is going to help you to have a high quantity of probiotics ready to heat the organic matter. And like this, you can put directly this solution in the system. So the water management, there is two different main trends to make this. So the first is to have the medium water exchange. The medium water exchange, it's you are changing the water maximum at 600% per day. In the biofloc system, this is a different technology. You don't make water exchange, or you can make one, it's semi-biofloc technology. So this means 20% at the end of the cycle. So the condition in medium water exchange is you are moving very fast, the solids. So you don't have so much organic matter in your system. The advantage of the biofloc is you are in a closed system and you are helping to have an heterotrophic nitrification directly inside the tanks. So something very important is the difference between the two systems. It's when you are working in water exchange, you have a risk of biosecurity. You always can have the possibility to introduce a pathogen in the system. So it's a risk. This is something that you don't have with biofloc. The input to make a difference between the two systems, we cannot put some input, in the water exchange, but it's very important to add sometimes in the biofloc some minerals, some probiotics, and so carbon source. So carbon source depend, there is different protocol of biofloc. I don't go into detail, but it's very important at the beginning to add the carbon source in the system. The limit that we observe, it's in the medium water exchange. We are using high energy because we need to provide every time water quality. So for this, we need a pump. We need to make a big volume of water preparation. So it's very costly in terms of energy. We are using a high quantity of water and we have the risk to introduce some pathogen. The limit that we have in biofloc and we can observe, they require high technical level. So you need to have a good technician to maintain and to control this production. You need to add some microelements in the system and you have to manage very well the NH3 peak and the NO2 toxicity. And at the end, you need to provide some good aeration because you have a high oxygen demand. So if I compare very fast the cost of production between a nursery and traditional system, I don't go into the detail, but what we can observe and what we know, it's the item the more expensive in the system of a nursery is the feed. But what we can observe, it's we have less expenses concerning energy, workforce, and water treatment in nursery system versus the traditional system. So at the end, if you are managing well, you have a production cost less than traditional system. So what we can see in nursery, the main point and the main cost of production is the feed. Why is the feed? Let me explain what happens in the feed. So what we know is the feed, everybody knows this in aquaculture, the feed drives the system. So when you are in a closed condition or in a very limited water exchange, the feed, when you start to make feeding, you have a part of the feed that is an intern, you have some feces, you have some excretion from the gills. So at the end, you are increasing the concentration of ammonium, example, but also some organic matter. And if you increase too much this concentration of organic matter, you have a big risk to kill the system and to have a risk to have high mortality. So it's very important, and the key of the success of the nursery system is to have a good precision of feeding and good feed quality. So we need to provide the exact quantity of feed, not so much overfeeding, very important to control. You need to feed when the animal is ready to consume and at the good location is very important. And for sure, in terms of feed quality, we need to have an adapted nutrition, good protein content, high vitamin levels, so different important raw material, and very important, the good particle size. So what kind of feed do we expect in nursery? So first, a diet that counteracts the stress factor from the transportation, from the counting, from the acclimatization to a new environment. I remember we are changing from hatchery to nursery. And after, there is also stress due to the transfer. The diet has to be adapted to very small animals. We are talking about, at the beginning, of animal of around 4 milligrams. So it's very small. So we imagine that we need to have a feed very well adapted and very small size. Also, what is very important, because we are working in hyperintensive condition, we need to have a good water stability with your feed. And nutritionally, the diet has to help you to reduce the FCR, improve the survival and the yield of the system, and for sure, shorten the cycle and to have a good growth performance. So what exists is starter feeds. There is different kind of starter feeds, but the quality can be different in function of the applied process technology. Here I show you 4 different technology and 4 different particles we can see in microscope. This is the crumble, the agglomerated, manumerase, and flake. So we can see the shape and the surface can be different in function of the technology. So Bernaqua decided to use the technology of manumerase technology because this is like this, we obtain the more spheric particles. It's very spheric particles. It's like sphere. And also we can see that the surface is very smooth. We have a smooth surface. We decided to develop 2 different products, one product at 60% of protein and one product at 45% of protein. So at the beginning of the stage, we are using the high level of protein, and step by step during the nursery system, we are moving and changing with the lower protein content. So we wanted to check this effect of the technology we are using for the feed. So in our facilities in Vietnam, in Nha Be, we decide to make a test where we start to evaluate the benefits of this kind of technology like manumerization. We make, in our facility with many replicates, we make this test and we can observe directly very fast that we obtain better final weight with the manumerase feed if we compare with micro-extruded feed and crumble. Concerning survival rate, we obtain more or less the same result, no statistic difference between micro-extruded and manumerase, but we can observe a difference with the crumble. And to finish, concerning the FCR, we can see we have a better FCR. So we are sure that the technology that we are applying help to perform better at the end in your nursery system. So concerning the physical properties, what we can see if we compare, if we check on the microscope, the crumble and the micro-extruded manumerase product, what we can see is first the shape. The shape is very different. And we make very simple tests that you can make it directly in your farm. You take and you make hydration of your product. You just put some drop of water on your product and you can check at the end the shape of your product. When we are making with crumble, we can obtain just a paste, something not so beautiful. All the particles are destroyed. And if we compare with the other technology that we are using, we can see even after 2 hours, we can see still the feed particles ready and whole. So something also you can do is the water stability test. So you take your product, you put in the water, you have a crumble, you have a manumerase feed, and you're just waiting, and you can see the leaching effect. So when you have a good technology, we can observe you have less leaching or no leaching if you compare with a classic technology like a crumble. So concerning the size, as I explained, it's very important to have a good feeding size, is we can see on the video on the right. You can see here, in fact, the shrimp, and the shrimp, in fact, you can see the legs. She can take the the feed particles and put directly in the mouth. So imagine if you have too big or too small feed particles that is not adapted to the animal size, you can lose at the end a lot of feed. So when we are comparing our technology in terms of particle size with the crumble, we can see we have more homogeneous size. So concerning also the technology we are applying to obtain this manumerited feed, we are working at cold extrusion. Why we want to work at cold extrusion? Because we can see the benefits to use low temperature. Very different publication we can find on the scientific literature, where we can see when you heat too much some protein example, you can have a protein denaturation. If you have a protein denaturation, the risk that you have is you can lose or decrease the digestibility of the protein. It's something that we can see on the graph on the left. And if we, something also that many people know, it's with temperature, we can also kill or destroy the vitamins. So some vitamins are very sensitive to temperature. So when we decide to work at low temperature, we want and we know we can provide a better digestibility and better performance feed. So what is a good feeding management in nursery? So as I explained, the size of the particle is very critical. It's very important to have a good feed intake and also to avoid a high body weight variation. If your size is not well adapted to the animals, the big animal can eat the bigger particles, and at the end, you're going to create a high heterogeneity of size in your tank, sorry. So it can be a big problem at the end. So something very important is when you start to make the switch between different size of particles, it's very important to go step by step. So I advise to go in a 3-5 days adaptation to make this shift between the particle size. Concerning the feeding, we advise to go in every 3 hours in the system, and during the day when you have a walker, and during the night, you can use an automatic feeder. And very, very important things, it's every morning when you start and when you enter in your facilities, you need to make siphoning to check what is, in fact, the init feed quantity to adapt every time. You need to adapt your quantity of feed to have no overfeeding and to have no organic matter too much in suspension. So normally the FCR we can obtain at the end 0.9 when you are working with good feeding management and good feed quality. And the feeding rates vary from 25% and decrease until 6.8% at the end of the cycle, so at PL 40 around. So just here, I don't know the, but this is an example of feeding protocol that we advise. So first, what we can see on the table on the left, it's in orange color cell, we can see we are making some body weight every 4 days. It's very important to every 4 days, take the animal and check the growth. The animals are growing well, we are on the good curve, is very important. Something also very important here, you can see we have 2 different protein feed content. So one is 60% at the beginning because we are transferring from the hatchery where they are eating very high protein feed like Artemia, but also at artificial diets at around 55–56% of protein. And step by step, we are decreasing the protein content to reduce the cost also of the system. And what is important at the end, it's with this protocol, we obtain at the end FCR of 0.9. So I hope it was clear. So thank you, everybody. If you have any question, we have the forum now. Thank you.
Thanks a lot, Thomas. And yeah, fantastic presentation. You're getting a lot of great chats. So well done. And yeah, thank you to all the speakers for very much covering the whole space here, right from hatchery all the way to nursery. So I think that was a fantastic job. Thank you so much. So this is the end of the formal talks, and now we're entering the Q&A session. So hopefully more or less for the next 30 minutes. There are quite a few questions already in the chat. There is also some in the Q&A box. So I've seen Lucia basically telling people to send those questions in the right place. Please do so. I have noted a few questions, but I'll probably get to the chat later. I'll start first with the Q&A box, if that's okay. So if you could all please come back with your camera on, we'll start soon. And what I think I might do is probably start from the top again, if you don't mind, and jump to Luk again for his some questions around his presentation. All right, let me just read through a few and decide. There's quite a few here. Okay, so I have one from Joano Henriquez for Luk. So this is around pilot and commercial trials. Have you seen different efficiencies depending on the species you would basically feed, or the production system? For example, shrimp against sea bass, or RAS against flow through, or ponds. Do you see differences there with your product?
Well, all the hatcheries, whether it's shrimp or fish, are already used to feeding Artemia in one way or another, as Instar1 or enriched. So the difference that can be observed is because our animals are not damaged through a mechanical system, and will have less leaching than other animals. And because of the fact that they are dewatered, it's more easy to get a standard in the quantities that are introduced into the tank. But it is an Artemia.
Yeah, absolutely. And so following on from this, do you have the nutritive value between Instar1 and Instar2? There is just a broader question here. I think you mentioned around the importance of staying at Instar1.
Well, I have to answer this differently because Instar-E has a different nutritional profile. It's difficult to compare because it's different. We add nutrition in the animal, like algae and UFA, high unsaturated fatty acids, vitamins, which are not there or less in the original Instar1 animal. So you're more changing your nutritional profile than you can compare it. So it is more suited for animals at a later stage. And to continue about this enrichment, because I saw there was also a question about the probiotics. Yes, you can also use probiotics as enrichment in the same way. Again, as long as the particle size is lower than 15 micron, this animal will filter everything what it finds in the water and store it into the digestive tract.
Thank you, Luk. I'll pick up on one question again for you, and then I'll move to another speaker to move around, and we can always come back if we have enough time. But this one is quite a good one from Justine. It's basically about your product. You mentioned it's coated with a plant extract. And I guess the question is around, is the plant extract just to preserve the Artemia, or the contamination of the Artemia, or does it actually have some bioactive properties for the shrimp? And then the second question is, what's the ratio of Artemia to this product in the final product, basically?
There must be a misunderstanding. What I told that is that when they are cooled down, they go into a cooling tank, an hibernated tank, where we also use natural herb extracts or plant extracts to fight off the bacterial load or Vibrio or whatsoever. Of course, part of that remains to the animal after the dewatering, but this is very, very little. But indeed, it protects the animal on further contamination when it's in the packaging, but also it functions as a prebiotic once it's eaten by the animal, whether it's fish or shrimp.
Yeah, thank you.
If I can add
yes.
one thing, and a question that I also that came back several times, that is people try to ask me what is the difference between using Great Salt Lake and other Artemia cysts. It is like this, that you have to know from where this comes. The Great Salt Lake cysts are smaller, and because they are smaller, they are more used in the fish aquaculture, because the fish mouth is smaller and they need these smaller animals to eat. But for the shrimp, it doesn't matter if you eat a small animal or a big animal. Nutritional wise, you don't see any difference in outcome of survival or dry weight. But it is like this, that many competitors who are selling Great Salt Lake, they use this as kind of, can I say, defense to say, okay, there are so many napoli, you get so many napoli out of 1 gram of cyst. But it's not the quantity that counts. It's the weight, it's the volume, it's the biomass that counts. It's what the animal can eat. Whether he eat this in 2 times or 3 times, or it's eaten in 1 time for a Russian Artemia, that doesn't matter at all. But again, for the fish aquaculture, it does matter that they get the smaller animal in the beginning.
Yeah, absolutely. No, thanks for adding those comments. So if you don't mind, Luc, I'll move to Leandro. There's quite a few for you as well. So I might start with a broader one from Alexandre Bédier. Hello, Leandro. Does the liquid feed work equally well on all shrimp species, and where were your trials tested on? So asking about Vaname, Monodon, and Stylirostris.
Well, this product was developed for Vaname. So we have been tested, as I said, in the last 3 years in our research lab. Of course, we try to explore different genetics. So this product was not developed to use only one Vaname genetic. So you can we can understand that this product was designed to meet the nutritional requirement of the Pacific white shrimp. Evidently, we may be going to have a chance to use in different species, but on the development process, I would say just Vaname. Besides, in terms of testing, we have been testing in our research center, as I said, and also in a beta trial, as I showed in the presentation, in the commercial system in Mexico. But that was only to release the product. Of course, we start to do different trials in different countries all over the world, including in Asia and South America. Talking about, of course, this is Artemia Ultra, but the older Artemia has been fed to the monodon for years and with a great result.
Okay, no, thank you. And following on from this one, there is a bit of a question around highlighting the difference between liquid feeds versus dry feeds, I guess. In your view, what are the key advantages there?
Well, you have key advantage. We have to understand that there is a different type of liquid feeds. The technology that Zeigler feeds has, the liquid feeds we have in the Zeigler program, it's maybe quite different than you can have in a different liquid feeds from different companies. But I can compare our liquid feed to regular dry larval diets. Our liquid feed does not leach. It's a very stable particles. It's a particles that was designed to with targeted nutrient values. So the nutrient values that you're going to put in, you have in this in the liquid product does not leach. So it stays available to the animals a lot longer than what you can have in the dry larval diets. Also, in terms of buoyancy, as I said, this new product has a very better buoyancy. During the development process, we use that as a target. And so if you compare our liquid feed buoyancy to regular dry larval diets, our liquid feed has a huge advantage. So if you put the dry larval feed, perhaps in 5-7 minutes, everything goes to the bottom. If you think it's not agitated. On the Artemia Ultra, that stay longer with a static system for over 30 minutes. So that's another advantage you have. Also, the liquid feeds we have, the particles are not dry; they are soft. So it's used to mimic the texture of an Artemia nauplii. So once the animal's trying to get a bite off that, they're not going to be a hard particle. It's going to be a soft, wet particles that's very close to the Artemia nauplii. So those are, say, the main differences between our liquid products to a regular dry larval diets.
Okay, thank you. That was a very good answer. And just to finish, there's a question around the composition of your easy Artemia diet. Do you have some rough idea of specs in terms of, I think that's what they're asking. Not sure exactly, but in terms of protein and lipid content, things like that.
The protein content is very similar to what we had in the old product. We have to remember that product is advertised to be, or we manufacture to be 73% of moisture. So on a wet weight basis, this is a 12% protein and 4.5%. Of course, what else? A composition, or what I would say. The product does not have regular Artemia in the formulation. So we know that, and some people maybe try to use Artemia as an ingredient, but this product does not have Artemia in their composition. So we have a quite few good ingredients, I could say, in this new liquid product.
No, thank you. All right, if you don't mind, I'll move to Jef. There's quite a few questions for you, and obviously we can come back. I'm scrolling down the Q&A, so I think I'm going through in order, but there's more coming in as we speak, so we'll see how we go. The first one, I guess, from a biological point of view, Jef, which are the minerals required for the exoskeleton to harden, and what is the role and form of calcium? Do you have any comments on that, or?
Yeah, but it's this biology 101 thing that you mentioned earlier, of course. Well, actually, yes, and it's actually a very nice question to illustrate something. So I think that the one who puts the question, he knows that, for example, all arthropods like spiders, insects, they have this exoskeleton which is sclerotized, but only crustaceans and also the myriapods on Earth, they also have a process of calcification. So where the exoskeleton is calcified. Now, why it is important to go to a point that I mentioned earlier, it's about the balances in the formulation. So for example, if I provide enough calcium, I have to be very careful that I don't mess up my phosphorus levels in my shrimp. So there goes my calcium phosphorus ratio. Calcium and phosphorus is also related to magnesium, so I have to look at my magnesium. Calcium uptake is also regulated by vitamin D, so I have to look at my vitamin D. So that's where I see, so that's where I link a bit, and that's what I said in this example for the calcification of the exoskeleton, but it's for loads of physiological processes.
Oh, that sounds great, thank you. And just following on while we are staying with biology, there's a question from Ron around, you talk a lot about sort of water to meat, but what about the hepatopancreas? What's the importance of the hepatopancreas for shrimp growth and health?
Well, the hepatopancreas, basically it's the whole digestive organ of the shrimp. So whereas we have liver, pancreas, bile, whatever in the shrimp, it is all combined, and it also, on top of that, it also functions as a major immunological organ. So it's like the main important organ involved both in nutrient assimilation, digestion, as in protecting the animal against the bacterial attacks. So it's quite important. If you go to the crustacean nutrition and for the book, it's like a whole chapter which is dedicated on the hepatopancreas. I'm not going to repeat the whole chapter over here.
Absolutely. So trying to find something else there. There's a question around, I'm not sure exactly the context, but what is the ideal composition and density of probiotics?
Oh, it's a bit outside the scope of the presentation because it was about fast growth, but okay, let's tackle that one.
Okay, thank you.
There is actually, well, in my opinion and in the opinion of other people, there's no such thing as a bad or a good bacteria. There is such a thing as too many bacteria and too dominant bacteria. So once you have bacteria which become dominant, in this case viruses, they have like a propensity to do that. They start their quorum sensing mechanism. They signal each other that there's loads of each other, and then they start mutating and attacking the host. So I cannot give you levels. The only recommendation that I can give you, try not to get bacterial dominance in your tanks. Try to keep diversified bacteria. And that is one That is one. That is why you also add probiotics if you add them. It's to keep your bacterial populations diversified, and if some of these bacteria, they also have some symbiotic, come from some symbiotic relationships with your shrimp, like Pediococcus, Bacillus, so the better.
Thank you. There's a question from Ning. There's actually several questions, but I might just pick the first one, Jef, is around, basically you're showing that, you know, you have through using the BioMar feed, you're getting much faster growth at the PL level. And I guess the question is around what the resulting effect is in the pond. What happens next, I guess, is the question. And along with that, there's questions around, you know, does that impact the PL transportation standard that is used in terms of you having bigger PLs to deal with?
So yes, so it's not only what like we have seen here. So we see quicker, faster growth in the pond and faster growth in the hatchery, and it has been documented that genetically, so the same genes are activated to promote fast growth in the hatchery as similar genes which are activated to promote the fast growth in the farm, which is kind of logical. Growth is kind of growth. So that is one thing. So yes, so genetic selection does do that. And secondly, as has also, it's Aqua Leader in Brazil who have published that one, that big post larvae, robust post larvae, that really, if you take care of your post larvae, apart from the genetics, that they kind of carry on this having been taken care of in the farm and keep on growing well. So it's both genetic as phenotypically, there is an influence of the hatchery growth and fast growth on the farm fast growth.
Thank you. All right, we'll move to Thomas so that everyone has a chance. And again, there are more questions in there. And of course, if you can answer them directly, that's fantastic. But Thomas, there's one around, do you need to feed Artemia to the juveniles in the nursery?
No, in the nursery, no. Sometimes some farmers are using Artemia in the transportation bag. So you have some Artemia, but you don't need. For this, there is a different reason. First, it's complicated and it's something else to do if you want to produce Artemia in your nursery system. And secondly, with the feed that we are producing and the feed quality we have today, we know it's not necessary to have the Artemia. Example, so when you are working directly in traditional system, nobody is applying Artemia directly to the pond. So it's the same for nursery, no need.
Thank you. There's another one here from Ramir. What's so important about an FCR of 0.9 when you can only achieve 0.228 grams in a 30-day nursery? I'm not really sure exactly what the question is about, perhaps about FCRs.
Something where what we can say is the final wave can change a lot in function of the density. So generally, some people work between 5 and 10 PL per liter. And if you go higher than 10 PL per liter, example, 15 PL per liter, you can divide by 2 the final weight. So something what we observe in nursery system is the density have a very, very important impact in terms of final size. So it's a very complicated thing. I don't know exactly, I don't understand so well the question, but what we know is there is no link, directly link between FCR and final weight. The more important is the density.
Yeah, absolutely. Thank you. There's one around biofloc. So do you add the carbon source directly to the pond? And the following question is there a protocol to prevent Vibrio bloom once you add the carbon source to the pond?
So concerning carbon source, so there is different protocol to obtain a biofloc. There is different possibility to do. At the beginning, it's very important for sure to add some carbon source. So one of the easy raw material to find, it's carbon source like molasses or sugar, very easy, very efficient because the carbon content is very high. So they perform very well and you can increase very well your carbon quantity in the system with these two raw materials. After, some people continue to use during all the biofloc cycle some carbon source. Me, after different experimentation, different trials, and I produce at production level also, not only in R&D. What we observe is to facilitate the work of the worker. It's after to finish to obtain your NO2 peak concentration. When you have a decrease of the NO2 concentration, you can stop to use carbon source. It's not necessary. So many people now start to work like this. So at the beginning we are using, and after we stop, after around 2 or 3 weeks of production, we can stop the carbon source.
Okay, thank you. And following on, another question around basically management of raceway. So this one is from Celine around the strategy to manage solid sediments in a shrimp raceway nursery system. I guess, how do you deal with the settled solids?
But this is the reason, because I talk during the presentation about, in terms of hardware, about your system of aeration. It's very, very important to create convection everywhere. So after different trials, you can check, and you need to have no place without convection. It's very important, because many times you can forget, example, to have one air diffuser somewhere or something like this. And what happened? It's all the feed or all the different eaten feed go in this area. And if you have a place like this in your system, you can have a big problem. So it's very important to well prepare your system, to well check what happened in terms of convection. Very, very important. So we need to avoid at the maximum the sedimentation. And sometimes if you have a place where you have sedimentation, if you know you have a settlement here, what you can do, it's every maybe twice a day, you just make a siphoning. Very important.
Thank you. Okay, so I'm scrolling through. There's 38 questions. Yeah, Luc, have you identified a few regarded? There might be a couple more for you there.
Oh, I just wanted to have a quick reaction on Thomas' explanation about the nursery. We do have quite a lot of customers who are using enriched Artemia in the nursery. It's like the same. He says yes, but you can also use the diets. It's the same in the hatchery. Of course, you can also use diets, but we always see that when you're using live feed, that you have an advantage towards diets. And people use it in the nursery as a booster before they go to the ponds. The reason why they don't use it a lot is because they have absolutely no experience in hatching Artemia. A hatchery at least has the experience in Artemia, but the nursery is located next to the grow out. They don't have any experience in Artemia, so they don't hatch it, but they do appreciate it. Thank you.
No, fantastic. Thank you. So there are a few questions for the full panel, and I might take one now. So immune enhancers like beta-glucan are one of the key functional feed ingredients for hatcheries, or it's a question actually. Are beta-glucan used? Would it help with the early life stages of shrimp? Any experience from any of you? And feel free to unmute yourself if you know about that one.
I can try to reply. I'm not a specialist. Maybe there is also comments of the beta-glucan is very famous as a feed additive. It was one of the main famous at the beginning of the feed additive business activities. It's something that is working well and help in terms of immune system. So it's something working well. But we can, in many times, add some feed beta-glucan in the feed. So it depends on the feed company and depends on the formulation. But yes, maybe Jef, because you wanted to talk about this.
As you say, so beta-glucan was one of the first additives they used. Beta-glucan comes in quite a bit of forms. So you have the 1,3, you have the 1,6, the 1,4, different ramifications, different functions. So yes, so it's not just any product that works the same, and you have to be so it works, yes, but you have to be very careful with the application and with the dosification.
Okay, well, I think that's pretty clear answers. Thank you so much. We'll stick with feed nutrients. This one is around the importance of feed supplements such as trace minerals. I think we touched on that quite a lot, but also omega-3 and astaxanthin. Anyone wants to comment around how important are those two for, I guess, starter feeds or even hatchery feeds?
For sure, some ingredients prove that there is benefits. So if we take the example of astaxanthin, there is a lot of publication that prove astaxanthin have benefits. They have benefits in oxygen circulation in the system. You have also other benefits like this, but some ingredients, raw material we can use in formula, like example, krill meal, can provide naturally some astaxanthin, more a good protein content. So as example, in Bernaqua, we like to use this kind of ingredients because you are providing a very, very good digestible protein, very attractant, and inside you have some astaxanthin. So it's something very important as an ingredient.
Omega-3?
Yes, I'll take that one. Well, fatty acids and lipid class has been one of my favorites in hatchery feed. So yes, they are incredibly important. So even when they started studying this, still in the ARC in Ghent, which were among the pioneers, there was a very clear effect of different omega-3s. So mainly DHA, EPA, but also linolenic and linoleic acids, which comes more from vegetable sources. Very important in the development and in the robustness of the shrimp. So quite high concentrations, much higher than in grow-out feeds are necessary, but yes, a clear and demonstrated role of the fatty acids. Also, how they are presented, when they are presented in triglycerides or phospholipids. So very important for a good performance of your shrimp post-larvae.
Perfect. Thank you. Looking at another little bit of a left field one from Hanno here around, is there any use or application of copepods or rotifers in early shrimp weaning? We've been talking about Artemia. Anyone wants to take this one?
Well, I think the problem there is, sorry, excuse me.
No,
yeah, go for it, Luk.
Go ahead, Luk.
No, just quickly, I think it's the same issue than with Artemia. That is that by introducing copepods or in some cases, you know, whatever live feed you introduce, you have to make sure that you are doing more good than bad. I mean, if you are introducing too many Vibrio together with your live feed, then I don't think that it's a good idea.
Yeah. Anything else you wanted to add, Thomas?
But from my side, what I know, so there are some companies that are starting to produce copepod and sell copepod, live copepod. There is and we can see very good benefits for the fish larvae production in many cases. I don't know so much example in shrimp production. I have no feedback from this, but I suppose it's working. After, it's a question of balance between Artemia, between hatchery diets, and also how you can how you can provide or supply this kind of product. But naturally, we are sure the larvae they are eating copepods for fish. For shrimp, I'm not sure. I'm not a specialist of the biology of the shrimp in the environment, but I suppose yes. After, it's always a question of offer, demand, price ratio.
Mm-hmm. Yeah, no.
Yes, if I may add, so yes, copepods, sure. Very good source, very good nutritional source for shrimp post larvae. It's part of their natural foods when they are in the mangroves and stuff. So yes, works very well. Same as rotifers. Why no rotifers? Works very well. Trials have been done. You win one day in the hatchery cycle. Already other trials were done 20 years ago. Then you have these worms, all kinds of worms that you can put. Yes, most of them work. The problem is place and labor in the hatchery. So you need a lot of place and a lot of labor in the hatchery. And that is basically, I think, the main the main stone why it's not more applied in the hatcheries.
Yeah, and there is another one around microalgae. Anyone wants to elaborate a bit more around? It doesn't appear that microalgae is being used as much, or is that because we were talking specifically around the mysis PL stage? Can anyone mention anything about microalgae there?
Hi, Cedric. I just want to go back to the subject. I think someone asked about the usage of Artemia in the nursery systems. And I saw a comment here from Mark Napolin. He mentioned that Dr. Samoa, which is everybody knows him and his results in the super intensive aquaculture systems. He strongly recommended the usage of Artemia in the nursery phase, in the early nursery phase. Since I had a chance to work with Dr. Samoa for 2 years in his lab, we noticed that using Artemia on the first days after stocking in nursery system, we could have a great advantage on an animal survival and performance in the beginning of the transition right after stocking.
Okay, thank you.
Yeah, I just highlight that since it is very easy to use for most of the nursery and the grow out system, they don't have a structure or they don't have the ability to hatch Artemia in local. So the advantage to use Artemia, which is it's a ready to go product, it's very useful in this type of system.
I'll elaborate a little bit on the algae. So yes, algae, depending on the algae, are nutritionally important. So depending on the algae, they do pack quite a bit of what you have mentioned before, or the question before, which is the essential fatty acids. So you can get, if you're mixing algae, you can get a good fatty acids profile, especially to your early larval stages. And even you will see PLs 5 and whatever, they will still be eating algae if you supply them. So a source of, for example, essential fatty acids and astaxanthin, and also very important, they reduce the stress of the animals by providing shielding in the tank. So shrimp, they have loads of predators. So when they feel shielded, hidden a little bit, their stress level is reduced quite a bit. And last but not least, of course, live microalgae, they also have quite a good probiotic effect. So it's not only microbes that you add, but also the algae have a probiotic and antibacterial effect.
Thank you. Okay, look, there is quite a few other technical questions, but I think it's best for people with questions to probably get some answers from the panelists offline, I think, because they're quite technical in nature. So if you don't mind, or if any of you haven't identified a question that you think is pertinent there, I think we can close the Q&A. It's been 35 minutes. I'll revert back to Lucia to close the webinar. Thank you all.
Yeah, for those questions that were not answered live, they will be answered by email. We will send them to all the panelists and they will answer by email. I want to thank all the panel for the great presentations and the great discussion, and thanks Cedric for the great job moderating. And thanks everyone for joining in. If you want to stay up to date on the latest news on aquaculture hatcheries, I encourage you to subscribe to our publications on our website, hatcheryfm.com, and follow us on social media. All our webinars are available on our website and YouTube. Don't miss our next webinar tomorrow, focused on feeds for shrimp hatcheries in Spanish. Goodbye.
Bye.
Thank you all. Bye-bye.
Okay, bye, everybody.